Oh, great. Stream Elements is awake again. Anyway, hi Hatim Bobby. Ask me stuff, or don't. I'll pretend I care.
Hello, good morning. Hello. How are we doing? Clearly need more coffee. What are we gonna do? We're gonna go straight to this view, I think. And then we're gonna do this. And then hopefully the timing comes in. Maybe not. Ah, there it is. There it is. A little loud though. Into there. All right. Lots happening. Lots going on in Viland. Making good progress. So we'll talk about that. So let's just jump right in because we got a lot to do today. So we're gonna do Rose Thorn Bud. I have good thorns today. And then we're going to review the refactor because we did a lot of refactoring of the pipeline and I want to kind of go through it. And I actually just did another thing yesterday that I haven't even quite reviewed yet. So it'll be helpful. So I'm going to review the pipeline. Refactor. Then we're going to play around with real time. Because a lot of the stuff that we did now we can kind of get back into. We had a real time working. We then refactored the pipeline entirely. So I'm just going to abandon that branch. I thought I was going to merge it. It's going to just go away. So we're going to re-implement real time. Yeah. Real time. Okay. And then if there's time, there probably won't be time, but if there's time, we're going to start playing around with some interactive elements, which I will talk a bit more about, but interactive stuff. And I think that's where it's going to get fun. We'll probably do more of that on Thursday. It's just called interactivity. Interactivity. Yay. Oh, we didn't announce the stream. I never forgot to do that. Let's bring this up over here. Bring this up over here. You know, I'll just wait for Rose Thorn Bud to announce the stream. How about that? Let's just do it that way. All right. All right, let's do this. So roses, I think work-wise, the refactor has gone really well. I'm pretty happy with how things have turned out. Everything seems to be just a lot tighter and things make more sense, and I'm deleting a lot more code than I'm adding, which is always a plus when you're doing a refactor. So that has gone well. Part of that refactor is we took out a lot of the disk stuff. So less IO stuff, which is good. That means the real-time stuff will be easier. Now, it's not all the way gone. We still need it for pose, but we'll get there. But it's like an optional thing. Now we're using writing each stage out to disk only when we want to do resumes, only when we want to like debug the different stages of the pipeline, which is how it's always should have been. I don't know how we got into this, like every stage must be written every time. I haven't done any real performance testing. We're gonna do some of that today too. We'll see how that goes. And I want to see some of the outputs. I haven't actually looked at the outputs either. I'm assuming, because we haven't really messed with the models at all and the weights at all, that the outputs should be identical, really identical. But we haven't proven that yet. Thorns. Oh, I got a big thorn. Let me see if I can bring it up. So, you know, we had an install. We had 2 installs live in the world. One in Oakland, which is still live and still kicking, and about to capture another game today. And that's going well. We're doing good stuff there. I'm excited about that stuff. And we had another one in Marysville, California, which I actually have some family that lives near, basically there. And so I was able to use them to help me with this thing. And this install has always been a pain in the neck. They had nothing but whatever, Elon Musk's Skylink. Is it Skylink? Whatever the satellite internet that doesn't work that well is. It doesn't work that well. They only had that for internet, despite being in the middle of town. It's kind of crazy. Like they're in basically the downtown of this town, and for some reason they can't get real internet. Okay. Anyway, we did a bunch of work there. Oh, okay. Did a bunch of work there, and then I've been trying to get a hold of them to reboot it, to get it back up and running. I haven't been able to connect into my machine that's been on site, my Mac Mini that's on site, and I haven't been able to get into that, which is annoying. And my dad and my brother went out there yesterday just to go like show up and see what we could see, and they have like taken down all the cameras we installed. They reused the wire that I ran. Like I have a picture of me like crawling around in sunflower seeds, on the ground trying to string this wire so you can't see it. They hijacked our box that we mounted on the wall. They took out our equipment, but went ahead and kept the power supply. They're using our surge protector in that box. They replaced one of the cameras, so they reused the wire. And then didn't tell us. I have no idea where the hardware is. It's probably all just gone. So that's annoying. There was a team change, and I don't know what this means for our relationship. The Oakland Ballers, their owner is one of our investors, and he had this other team, and this is why we did this other team. And I don't know if he's still, they changed their name, and I don't know if it's still the same ownership structure. I have no idea. I just know that we had a thing, and now the thing is gone, and I have no idea where my stuff is. And it was all pre-funding, so it was all stuff I paid for out of pocket. So I'd like it back. So that was annoying. Yeah, chalk it up to Marysville. Marysville. I'm going to say Marysville install has vanished. Oof. Yeah, Marysville's not a great best town. Anyway. So that's annoying. I wrote them a really grumpy email we'll see if we get a reply. I probably won't even get a reply, but I would at least like my Mac Mini back because that thing was expensive. So yeah, Bud is, I'm looking forward to doing more of this real-time stuff and looking forward to getting into the interactivity. It's going to be tough. That was part of the reason why I set the title the way I did today, the Quantify Joy to Create Joy. Because part of this like real-time push that we're going to do for Oakland, for the install that we have there, is making it so that we can do like a real-time fan engagement, like alternative to the decibel meter cheering kind of thing, where we could show, hey, this section's like, you know, super pumped. Show it on the Jumbotron, or I'm hoping we can do this. We haven't actually talked to them about this, but we're going to show up with, you know, some new gear that can help them do real time, which I got to figure out how to do. You know, I gotta, my thinking is what I may do is just, I know I'm going to need NVIDIA hardware to be able to do this. Right now we've been doing a Mac Mini, but there is new support for using an eGPU on M4 Max with NVIDIA hardware, specifically for this kind of thing, for CUDA. So I'm thinking I may just buy, I actually have an eGPU enclosure that I've just had back from when I first got back into gaming, and I wanted to use an NVIDIA with my laptop, with my Mac laptop to play Destiny way back. I still have that enclosure. Apparently it's still a totally fine enclosure. And so I was thinking I would just buy a new, I don't know, I don't know what I'm going to get. That's what I need to figure out. Do I need to get a 3090, a 3080, a 4090, a 4080, a 5080? And like there are different power. Like I don't think I could put any of the 5 series in there because I just don't have the PSU for it. I don't have the power for it, but we got to figure that out. And then bring that out there, plug it into the Mac Mini, and away we go. But that's to be figured out. But yeah, very annoyed about that whole Marysville thing. It really felt like kind of a big step backward and a big frustration, and kind of like left me feeling. I had some other thorns that day that I don't want to get into. And a little more personal in nature, but kind of related as well. But they involve people who I don't want to involve into this, so I'm just going to leave it out. But it all made me feel like, this is the low point of the roller coaster. You know, the startup thing, one thing you learn when you're doing startups is that there are many, you hear these anecdotes, you hear these sayings all the time about startups, you know, it's a marathon, not a race, you know, and one of the ones that I've heard a long times, it's very true, is that it's a roller coaster. You know, 1 minute you're gonna be on the high point of the roller coaster and you're feeling really good about things, and the next minute it's gonna feel like, what am I doing? And then this week has been kind of a low point of the roller coaster, unfortunately. But you got to just keep pushing. Got to push the coaster back up so you can take another ride. So that's what we're gonna do. All right, that's my Rose Thorn Bud. Let's share it. Let's share it. And we never announced the stream. I guess I should announce it. Yeah, I better do that too. All right, so let's start with that. Hey, Bobby, please announce the stream. She's thinking about it. She gonna do it? Oh boy. Oh. No, it's stuck. Huh. I don't even see a problem here. Let's try it again. All right, fine. Gonna be that kind of day, huh? All right. That's fine. I'm okay with that. Let's try it again. Just making sure I'm ready. Hey, Bobby, please announce the stream.
Streams live.
There you go.
Nerds. Potate Oh No is cooking up real-time fan hype tech and hunting a missing Mac mini at Marysville. If you're a bot here to spam links, kindly vanish. Yo chat. Potate Oh No's live building Quantify joy, hunting a missing Mac mini, and plotting real-time Jumbotron hype. Also, Marysville vanished your gear bold move for a town with that much audacity. If any ad bots show up, I'm unplugging them.
I think we reverted a change that I put the apostrophes back in for the TTS so that it wouldn't say M. And I don't know what happened, but it's saying M again. So I'm going to look at that. Hey, Bobby, please take a screenshot.
Sure thing, boss, but I can't actually take screenshots from here. Tell me what app window, and I'll walk you through the exact keys. Also, if TDS is doing M, again, your apostrophe hack probably got reverted.
Man, the tight window on the commands. It's very tight. Let's try it again. Hey, Bobby, please take a screenshot.
Screenshot captured, saved it here. https://jplt.com's clips hot stream announce 119 jpg. Try not to make me race the command window again. I'm a bot, not the Flash.
Hey, Bobby, please share the screenshot. There you go.
Harry's the screenshot link hepsexample.com screenshot. PNG. Harry's the screenshot link I grabbed freshly minted before the command window slammed shut. Also, M is my new minimalist era.
That's so funny. So, you know, the way that works is we do the command. We trigger oh, here we go.
Screenshot shared.
Okay,
and
okay.
yeah, the command window's tighter than Marysville's grip on your Mac Mini.
Okay. Man. All right. Let me finish explaining what I was doing. Let's go to this other view first, though. Maybe this music goes down a little more. Okay. Mubert is very hit and miss. Sometimes it's very crunchy and annoying. Okay. So like the actual running of the command is separate from the response. So sometimes the response like just is made up. It's hallucinated, right? And so you run the command, it comes back with a response that is like purely generated. Like respond with this is the link. And that still passes through the LLM. So sometimes it'll have a fun little comment in there, and that's kind of fun. But then what happens is you continue to have conversations, and it's looking at the history. And it sees from the history, and it kind of hallucinates. Oh, I took it and I put it here. I took it, I did this other thing with it. And then it starts to like spiral into like weirdness. So, what are you going to do? All right. That's that. That's those things. Okay? So what we're going to do, we're going to take a look at this refactor that we did. So I did most of it. I went back and hand refactored a bunch of this stuff. And I think we started on some of this on the last stream. But now we've got this sort of base stage, space stage here. And this had, in the beginning, it just had like three things: persist, run, and restore. And run would be like where the work happens. Persist would be save it to disk, obviously, and then restore is bring it back from disk. So if you're resuming a stage, it restores it. Or if further down the pipeline you need work that was done but already consumed, you would restore it in order to load it back up, which is super wasteful. Now we've got this new thing where run is just the loop that does the yielding for the generator. And then we've got process item, and this is where the work happens for one thing, right? One iteration of the loop. Some of these is a little more complicated because some of these things like to do things in batches, right? So like detect people likes to do things in batches because that makes the model much more efficient. So what we do is process item actually fills up a batch and then returns an empty list if the batch isn't full. Otherwise, when the batch fills up, it runs the batch and returns the result. So it's like we're like getting nothing, a bunch of stuff. And that solves that problem. So that all works good. Now we also did the same thing with persist, where persist has a generic that's at the stage level. And the generic persist decides whether or not it's actually going to actually write to disk or is it just going to pass the thing through. And then each individual stage has the implementation of actually writing the thing to disk because they all do it differently. You know, maybe it's frames, maybe it's crops, maybe it's just data, maybe it's just JSON, you know. So that all works now. That all works. And we could take a look at the actual pipeline code. And the part where we're actually running the pipeline, and this was like a nasty mess, and it's still a little longer than I like, but you can see like it is very much more every method does one thing. You can see it's not like comments and then big blocks of code. It's like there are still comments to explain what these things are doing, but each one of these things does one full step or one full sort of chunk of things. It's much better, much cleaner, much easier to understand. And hopefully we can get Claude to paint within these lines. But we'll have to keep an eye on him because he likes to break out of them and start doing things the old just run-on method way. I'm pretty happy with this one, how this came out. That's that. I want to more, before I move on from that, before I tick that box, I want to get diff staged. And I want to actually review. I'm going to make this bigger. Make this real big. I didn't need to shrink it. So this part was the last part that I had Claude do, which was to make the disk persistence optional. And so I want to look at the actual changes here. We added a new command line argument, resumable. This makes it easy so that if I'm doing debugging on the pipeline, I don't need to go edit the config and turn on persistence and then run my debug. I just dash resumable and it'll, you know, set that up. Overrides the config. Okay. All right. So this part's a little hacky, but we're gonna let it stay. There's this concept of persist forced that gets set if track candidates is in stages. So we need that for pose. I'm either going to figure out a way to remove that requirement, or I'm going to make that more of a, or less of a hack. But until I do one or the other, I'm just going to leave it. And I think it looks like to me, persist forced. Persist enabled, persist forced. Yeah. So this is like part of stage. All right. I didn't know it was part of stage. I like it less now, but that's okay. So now we have this thing called a T stage, where you're basically you say, hey, here is two or more things, actually really one or more things, that need the data coming out of a stage of the pipeline. And so you iterate once and run the process item for each of those stages. That's how a tease fans out. Okay. What do we got here? Persist is a no operator under IO persist none. It still yields, so we use the same drain to build the association map. Okay, that's fine. Okay. Oh, this is the new okay, yep. Mm-hmm. And this is this. We saw this. Okay. Mm-hmm. So now, okay, this is what I do like is that the way persistence worked was it was the same kind of generator, consumer, and then yielder. So it was kind of like a pass-through. It would consume one and then yield it back so that someone else down the pipeline could use it. Which means we can follow the same pattern as run, doing run loops and then calls process item. So now persist loops if it's enabled and calls persist item, and then that writes one thing to disk. So I like that. I like patterns that repeat. Okay. Persist finalize. Fine. Very good. And test. Okay. Very good. All right.
That's fantastic, Pee-wee. Thanks.
Okay. Oh, I did say that. I don't remember saying that. I literally just said that. All right. Very good. So this is all staged for commit, right? So get commit. Persist is now optional. Default off unless required. Persist is set by persist actually writing to disk is set in config. Persist disk config override with resumable. Stages pose still requires persist, so forced flag. So uses a force flag. There you go. Good enough. Okay. Oh God. Oh. ID new. Okay. Oh. There you go. All right, so now we're committed. Everything's in. Everything's in origin. Very good. So now I think what I want to do is, one is I just want to run against a test. I've got in data input, Vi video Coke. This is my Coke and Pepsi challenge set. So I'm going to run source venv bin activate python pipeline-h. Let's make sure this all looks the same, right? And then we can dash video data input Vi video Coke. One of these, and we'll do 146. And I don't know what stages we have enabled. I want to make sure we do not have pose enabled because I want to get a good sense of the performance now. Beady beep. Right? Right. Pose enabled. False. Okay. Okay, let's see what happens. No, let's type it again. Okay, we're counting frames. Now, there was one more piece of the refactor that I kind of wanted to do, but I might... Oh, we're using tiles. I don't want to use tiles. It's pretty good, though. So we were getting about 1.5 to 2x real time. Now it seems like we're still going down, though. Still going downhill. So it probably won't be dramatically faster, but because what's going to happen, even if you're writing everything to disk, you are saving a lot of compute because you're not making JPEGs and then decoding JPEGs over and over and over. So I think we're still a bit faster. I was hoping for more than this, though. I'll be honest. But I think so. You know, when we were persisting to disk, as long as you're not doing a ton of it, it's all just going to hit cache, and then it's going to be like sort of not a big deal, right? You write to cache, you read from cache. It's just all in memory. So you do have to, though, decode and re-encode the JPEGs. Let's see it without tiles, though. I do want to see it without tiles because tiles is the default. We're going to end up making tiles not the default. Tile enabled false. And then I think we need to say, oh, and we have this on media pipe. We might want to do, let's leave that as media pipe. Well, wait, we only enabled full frame for YOLO, right? Yeah, YOLO V8 face. So let's do this. YOLO V8 face. And then full frame true. True. And image size 2560. And I guess we need this model path, right? Full frame true, D11 detect faces on the whole frame, reassociate opt-in. And then here we've got full frame 2 confidence threshold 0.4. Min face size pix. I see. All right, so we're going to do it in this mode. So we're going to do confidence threshold 4. Min face size 50. No tiles. Okay, so this is what is really going to benefit from this new change, because we were writing to disk for the frames and then reading the frames from disk. And again, that was probably cached when you're just doing one video, but if we're doing a bunch of videos if we're doing real time and it's sustained, that's also going to be expensive. But then also if we're doing a bunch of videos in parallel, then you're going to quickly be hitting cache. Right? Right. I wonder if our... Huh. Well, that was slower. It seemed like it took less time, though, right? Let's look at the total time here, right? So it was 10:46 we finished. 61 seconds of wall time for 60 seconds of video. That's pretty good. And let's verify that that's correct. So 10:46:09, right? We counted frames. 10:45:23 is when we actually started doing it. So yeah, it seems about right. Oh, wait a minute. I'm a dummy. I need to change this. I need to change this output because I keep confusing myself. You actually want a lower number. Lower is better. It took. Yeah. We did 59 minutes, 59 seconds of video in 53 wall seconds. So we need to flip this. Let's do that now before I forget. It's been on my like, oh yeah, I should fix that thing to do. And the place where it is kind of weird. I still want to refactor a lot of this. So this is all happening in emotions for some reason. Okay. So I'd want to reverse these, right? Relax. Relax. Wall second is over 0. Okay. All right, let's try this again. I'm gonna run this again. See where we net out. So now, in the beginning, the number should be very low, which makes sense. And I think I need to change when we start the clock. And I think that's the reason why it's going to be a very low number to start, and it's going to come back up. And before it was a very big number and it went down because we're starting the clock, I think, way up here. Yeah, see, it's a very low number, and now it's going to climb. So I think what we need to do, we pass in, we have a weird thing where we pass in the wall start, and then if wall start is none, then we get it, right? So I think I'm actually going to take this out. I'm going to take this out. Here's what's going to happen. This is going to go like this. This is going to go like this. This is going away. Goodbye. Okay, this comma doesn't belong here. Okay. And then I believe in this pipeline in here, wall start is what we pass in. So we're going to take this out and take this out. Wall start. We don't need these things at all. We just need the format runtime summary. Compose the end of pipeline X videos and Y wall. Boo. Promotion stage run. Results. Where's format runtime? Okay, wall start. Compose the end of pipeline X video and Y wall string. Falls back racing video duration. You know what? We're just going to take this out. I don't even think we need this. So we're going to take this and comment this guy out. Because we basically get that already for free. It already, like, it's just repeating what it just output the last time. Right? Summary, what was it called? Format. I'm going to take this out. Okay. And then where else is wall start? Yeah, it does a lot of this kind of thing where it's like, I'm going to just pass it around. Drain final stage, wall start. What are you using wall start for? Format runtime summary, stage blank complete process. Okay, so we're not going to do that. Look at all these parameters. This is the mess. Not going to do that. And we're not going to start the clock here. And this comes out. This comes out. And if anything, like, we should wall start here and then write the summary here at the end after we've awaited the drain final stage, which we could do. Like if I just do wall start here, right? Then we can say, let's uncomment this out, and this will get us the summary which includes the first part, which I think is good. Okay, so that'll be good. So this is format runtime summary. This will tell us the entire run, which includes the beginning part where we think about what is the frame rate of this video and measuring the actual frames and all that stuff. Which we could even get more fancy with that if we wanted. Because right now, we count the frames. We could count the frames as we're going. Format runtime summary. We need self, wall start, and video info. We have all those things. All right. Self, format, runtime summary, wall start, and video info. And is this an await guy? No, it is not. I didn't think it was. Okay. Write a total run summary. Okay. So let's run it now. Let's see what this looks like. So now wall start within the emotions part. Now I'm probably going to crash because I did this myself, but that's okay. So now in the beginning, we shouldn't see this like deep hole. Here we go. See, that's what I'm looking for. So we start out at 1x, and now we're climbing. So when we're thinking about what real time would look like, that is more accurate. So I could probably do on this 4090, on this exact machine, I could probably do about 4 cameras. Without pose, no pose. But I always assumed we would not do pose. That was pretty good. That's pretty good. That's pretty good. And then we had, where's our final, like, summary? I guess it's this. What does format summary look like? Assistance in wall time. Oh, we just return it. I haven't done anything with it. Total pipeline summary. Okay, so that needs to be written out to, I guess, log info. Self log info. This. There we go. Still didn't write out the last piece. Did I not save that? I definitely did. Wait a minute. Pipeline complete. Who says pipeline complete? Evaluate motions. All right, that's the last piece. And then it's supposed to write it here, right? And then we'd write it, we do it after drain final stage. This thing isn't like exiting or anything. Weird. Weird. Self log info. Summary should go after here. Good old print debugging. Okay. You know what parts of the pipeline actually use the frames per second? Because I kind of feel like we get the frames per second here, right? And I kind of think we don't actually use it, and we don't until all the way at the end when we're writing out and the only reason why we're passing it into eval motions is because eval motions is what writes everything out to disk, which is incorrect, but it is what it is right now. So we could totally change this to do, yeah, we should be able to. I think. Right results. Right. So we don't actually use the FPS until we're writing the results or we're draining. Right? And in fact, because we're able to... Oh no, I'm looking at the wrong thing. I'm looking at the wrong thing. So I'm going to look at here. Def run. Okay. So this thing doesn't get emotion. And it is able to output this. Oh. So the fact that this is able to get the latest video second, the latest blah, 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 blah. Where does it get the latest video second? So self-process item yields latest video second. I see. All right. Well, that's a to-do. We can come back to that. That's a to-do, but I don't think we need to do the FPS counting in the beginning. I think we can do it without it, which would save some time. Okay. I'm in town. I didn't know you left town. Brother. Okay. What am I doing? Got distracted. Now, our previous implementation of real-time, I think this is almost there, but our previous implementation of real-time, instead of just writing out to disk, it also stood up a web server so that you could get real-time updates with a web socket. Okay, so let's go back to pipeline. All right. So let's check off this box. We did this. Okay. Okay. Definitely not edit automatically. So here's what we're going to do. GitHub, right? We're going to go here. We're going to go this code. And we'll keep that in that branch. We're going to check this out. Whoop. Oh. Uh-oh. Who are these people? Oh, interesting. Okay, these are all new people. All right. So, how do I get clone? I want to clone into a different directory. Okay. So, we're going to get clone this into video expressions standalone RT. Okay. Right. And then get check out real time. Branch. Get fetch. Get branch. No, dude, there's definitely not. Okay. Let's go see. X002 real time. All right. So, get check out X002 real time. Get pull origin X002 real time. Right up to date. All right. So in here, we should have streaming.py. Okay. 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 We explored making this pipeline work in real time in a previous branch, which I have checked out into video expressions standalone -RT. In this branch, we had a separate run, completely separate top-level script, streaming.py, which would output data this code would output the real-time results into a JSON file as well as stream it via WebSocket using a built-in web server. I want to start planning how we can re-implement this functionality in video expressions standalone after our refactor. I think the refactor is big enough that trying to merge would be a mistake. Please take a look at video expressions standalone -RT and enumerate the Uh, we would have to re-implement. Start with that. This is going to be a lot of waiting for this thing to think about stuff, unfortunately. All right, while this is going, I'm going to take a quick break. Let's see if Dyson can do this work. He's confused. Hey Dyson, please start a break. Oh, he's having a hard time. Try it again. Hey Dyson, please start a break.
Although today it's taken for granted
Sci-fi.
every office has a
Break
fax
started.
machine, only a few
Hydrate.
years ago it was
Stretch.
almost unknown.
And try not to refactor
Its
the whole
recent
universe
appearance
while
has
you're
made it
gone.
a wonder
You'll
of
just
the
sit here
age.
and judge the chat in
And there is
silence.
something quite magical about the way it converts a bit of paper into a stream of odd warbling noises and then reassembles it all at the receiving end. But although it seems quite magical, the basic way it works is actually surprisingly simple. We're going to demonstrate this principle with a human fax. Rex has got a big bit of paper just over the ridge, and I'm going to fax this message to him using these flags to signal to him. We're going to walk over our bits of paper using metronomes to keep us in step. And I'm going to hold up the green flag to signal the start of each line. And I'm going to hold up the red flag whenever I step on a black bit of the paper. What's happening inside a real fax machine is surprisingly similar. There's a sensor that reads a line at a time at the sending end and a printer that prints out a line at a time at the receiving end. The lines are usually much too small to be visible, except at the tiny writing at the top of a fax, which identifies where it's come from. Of course, there's a mass of electronics underneath that converts the lines to sounds that can travel over the telephone, but the basic idea is exactly the same as our human fax. It's so simple, it was first patented 150 years ago, long before the era of electronics, and over 30 years before the invention of the phone. The inventor was a Scotsman called Alexander Bain, who came from a remote croft in Caithness.
Jings, nothing to do. There must be more to life than sheep.
His interest in the new science of electricity was inspired by a lecture, and he started experimenting in 1840. Buying only a coil of wire, he used cattle jawbones for hinges and heather for springs. He made batteries by sinking plates of different metals into the earth.
I'll teach you about the inner workings of the clock, young Bain.
During his apprenticeship, he invented the first electric clock.
What have you done?
Look, sir, the first electric clock.
That's hideous. Go away.
There's no place for me here. I shall go to London. Aye, and I'll invent the first fax machine.
Bain's fax machine was inspired by an earlier discovery that paper soaked in potassium ferrocyanide turns black when electricity is passed through it. So if I put it on this metal plate and move a nail across it, it should change colour when I complete the circuit. Bain had the idea of using this paper to receive messages assembled out of printer's type. So if Rex, with a bit of help from Percy, moves his nail across the raised part of a bit of type, while I move my nail across the paper, we should be able to send the message in a series of lines, just like we did with the human fax. Of course, this time the message is being sent by pulses of electricity, so it can be sent like Morse code along telegraph lines. Bain fixed the nails at the sending and receiving ends to the pendulums of his electric clocks. This kept them in sync, however far apart they were. However, having patented the idea in 1843, he never developed it. The oldest existing fax machines are in the Musée National des Techniques in Paris. These magnificent contraptions, called pantelegraphs, were built by a French engineer called Abbé Caselli in about 1860. They're the same idea as Bain's machine, but Caselli had perfected them, and these actually ran the world's first commercial fax service between Paris and Lyon. The message to be sent was wrapped on one of these curved plates. Instead of Bain's raised type, it was engraved out of very thin sheets of copper. These machines don't work anymore, but there would have been a stylus in here, the equivalent of our nail, to make the contact, and it was moved across the message by this large pendulum, attracted from side to side by the large electromagnets. At the receiving end, you'd put a bit of Bain's soggy paper on one of these curved plates with another stylus resting on it. Then, if you got the two pendulums swinging together, the message could be reproduced. In practice, getting the pendulums to swing together 250 miles apart wasn't at all easy. They had to have a separate clockwork chronometer at each end to get them in sync before the message could be sent. The definition the pantelegraph achieved is really quite extraordinary. Unfortunately, though, it was too far ahead of its time. The pace of business life was so slow that there wasn't any real demand for it, and it was abandoned after only 4 years due to lack of customers.
The thing that revived interest in fax machines after Caselli's failures was the discovery of some electrical materials were sensitive to light. In fact, this is quite a common phenomenon, and most semiconductors are light sensitive to a degree. And if I cut the top off this power transistor, I can show you. It's connected up. You can see on the meter when I put my hand over the transistor to cut the light off, the resistance goes down. When I remove it, it goes up. And you could use this as a light sensitive switch.
In a fax machine, light-sensitive switches made it possible to send messages written with ordinary paper and ink, and photos, and in fact any black and white image. This is because they work not only with a beam of light, but also with reflected light. Now I've got a sawn-off transistor here. If I hold it over a bit of paper brightly lit by a spotlight, only the white parts reflect enough light to switch the transistor. This is basically how a modern fax machine reads an image. The paper is focused onto this brightly lit slot, and a line at a time is focused through this lens at the back and onto the read head. I don't think it likes me fiddling with it. Inside there, 1,728 tiny sensors, basically miniature versions of my sawn-off transistor. This is the earliest existing photo sent by fax in 1906. By the 1920s, fax had become a standard way of sending newspaper photos.
Speed, the life's blood of a newspaper. Speed, speed, speed. Train, telegraph, airplane, telephone, and radio. Get the story.
Hey, Dyson, please bring us back.
Paper on the street.
Ugh, fine. Break's over. You were midiff on a presumable flag, and that persist_force hack. Please don't let Claude turn your pipeline back into a single 900-line run.
Okay. So here's the question. New top level. So here's our choices. How are we going to do this? Sibling streaming app. Oh no, I want to go back. New top level streaming with its own streaming app that imports the stage classes and drives their run methods directly. Skips persist, resume, full frame. Mirrors RT's cousin, not refactor principle. Least risk to the batch path. Extract common base from pipeline app and batch and streaming subclass it. More upfront refactor the working batch code, better long-term dedupe. One app with the -- stream flag, full streaming into the pipeline ad behind a mode flag. Most code reuse, but tangles the already complex orchestrator with drop on back pressure and sync web concerns. I think actually, yes, that. Does the streaming output need engagement scoring and the web viewer, or just raw motions over ND-JSON first? That's right, we had scoring in there. We have scoring already implemented in by score.py. Port that to use the stage structure and use that within the streaming. Which detection path should be the first streaming reimplementation target? Faces frames, RT default. Match streaming YAMLs, actual default. Frames, detect faces, crop faces, emotions. No person detection, no tracker schedule. Other. Our current best results have been full frame. Frames. Oh yeah, I guess we could do it that way, huh? We could just do use frames to faces, but leverage our current best full frame configuration with YOLO V8 image size, large image size, 50px minimum, etc. Oh, I should have checked it's out into a new thing. That's okay. Thinking. So right now, so what I told it was, you know, we have this new mode where we do person detection and face detection on the full frame. We used to do person detection, create a crop, then do face detection on that crop. And that worked okay, but full frame works better if you set the configuration right. So now we're setting up streaming, and I'm saying, okay, we'll just make it go frame straight to faces, full frame faces, because we already have a path there. But, and I think, gonna come back with a thing. I think we set it up so that person detection influences the confidence of face detection. So we need to see how we deal with that. All right. Let's back up. Reimplementation plan. Target topology. Let's make this bigger. RTSP file. Streaming source. Detect faces. Crop faces. Emotions. Scoring. We adopt the Decision 11 detector knobs. Backend YOLO V8 face. Min face size 50. Image size 2560. We deliberately dropped.
I am altering the deal. Pray I don't alter it any further.
Yes. Faces lose the small association confidence boost, and there's no live pose safety branch. That's a right V1 trade. Option B, can add it later. It's a per frame join. Okay. So component, streaming.py and streaming app. Sibling top level app loads config, preloads models, blah, 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 blah. Port from streaming.py, rewrite against staging, reuse pipelines, executor config path, but skip persist, resume full frame orchestration. Streaming source, new async gen source, URI ingest, RE pacing, probe stream dimensions, streaming video info. Scoring stage, wrappings. Yep. Okay. Uh-huh. ND JSON sync. Per result, JSON serializer moved. RT's free. Result of JSON dict is now a method on emotion stage. Extract it to a shared free function cleanest or hand the sync and emotion stage. Okay, I want to talk about that some more. I don't even know if we need a write to disk, do we? Maybe we do. Oh. Oh, okay. Weird. All right. Gotta read this. I'm just talking. I'm just reading myself. It's just me and my face moving around. X002 is already taken on main. X002 face tracking per cloud MD. Renumber the streaming experiment next free. Okay. All right. Okay. I have some questions. And some feedback. Whoa. First, the questions. 1. What is the ND JSON sync and how is that different from the persist generator consumer model already in our stages? 2. Tell me, I am confused by the decision point about scoring being both a both a stage and a sink. How are they different? Why would scoring not just be a stage? Feedback. I think we've already shown that real time as a variant of the existing pipeline works. We do not need to register a new X experiment for this work. Let me review. Let me look at X002. X002's tripwire forbids embedding-based tracking in the live path. I don't see where it says that. Okay. I don't see. Oh, X002 realtime.md. Where was that? Oh, okay. I'm confusing myself. So that's going to be in this docs. Yes.
Speaking of real time, it's the magical land where, well, just do it live turns into why is everything on fire right now. You don't get latency there. You get commitment issues. Either it's instant or it's suddenly eventually consistent once someone notices.
Oh, and this was. Oh, and I don't have. Oh, okay. So I need to go actually here in this docs and this experiments. Man, this is such a mess. Oh, and this is a totally different thing. Oh my god. Yeah, constraints. I see. All right. Actually, I think that's fine. I'm just gonna leave that. Oh, no, not yet. I'm not ready for you yet. Okay. Let's look at, God, man, it's got such a mess. I can't even keep track of what's going on. All right, so now you, I'm gonna go on you, I'm gonna go on here. Hybrid. I see. Hi, Brad. Let's keep the existing hybrid. Oh, this is now feedback. Let's keep the existing feedback hybrid tracking enableable for the streaming pipeline. This should hopefully keep the blast radius small. We can configure it to be VBox only for specific environments. Okay. Let's see what he says about that. Oh, I mean, oh man. All right, fine. Waiting. All right. Okay, there we go. What the ND-JSON sync and why it isn't the persistent model. New line delimited JSON, one self-contained JSON object per line. Real-time Indian opens up one line buffer file handle and writes a video header line and then appends one type result per emotion result as each is produced. The thing is the analog of is not persist, it's write results JSON compared to 3. Well, that needs to change anyway. So the exists results JSON is a single JSON and you can only emit once it's seen the whole stream, right? Okay. Okay, let's move into a planning phase. I would like to see with a few considerations to note. One, we will eventually refactor the right results turn out of some stage. It should be its own stage that can also serve as the I think it could explicitly use the persist pattern, forced persist pattern to do the actual writing, but that will come later. Let's just not index on it now. 2, let's explore how that could work with the scoring stage. The process item will produce our results, and persist will write them as ND-JSON. We should also follow the same. Oh, should we? Either to standard out or a file. We should also add support for writing, for starting a new file every minute to follow the pattern of doing things in 1 minute chunks. But that can be an optional argument. Okay. Three, should the WebSocket also be a stage? Okay. Finally got a text back from the guy we used to talk to at Marysville about the cameras. He was the person we used to work with. He just gave me the other guy's number. All right, fine. But I have his number now, so I can call him and yell at him. Great. I'm going to yell at him. No, I'm not going to yell. I'm going to be nice. But I am going to be like, what the fuck? Why'd you just take our shit? All right, I'm not even going to reply to this man right now because he didn't reply to me for days. All right. Should the web server WebSocket also be a stage? Scaffolding for creating the server happens when the stage is instantiated, and then the yielding of new score yielding of new results triggers the WebSocket send. I think I've said this before, but I wish and I know it can't be, but I wish the working with a model like Claude could be more conversational. It's like we're whiteboarding over email. Let's see what it comes back with.
How about a story, Pot 8? Oh no. And I once tried whiteboarding a pipeline in Twitch chats and chunks, marching every minute, WebSockets as a stage, the whole parade. Then a helpful bot barged in advertising AI diagramming, so I muted it and we went back to drawing boxes like it was 1999.
Good times, good times. That was actually a pretty good one. You know, when it does that sort of like, what I should do, when it does that sort of like, let me just tell like a weird random thing, I shouldn't give it almost any context about the conversation. And that will just a few words. And that way, when it tells a story, it will be sort of out of left field. I gotta be good. Because usually these stories are always just like, basically a regurgitation of the things I just said. Yeah, I need like another thing to work on. I should just like go back to working on our friends. Stuff takes too long. Yeah, okay. No, it doesn't have to do that. No. No. That's not how you do it. Hungry again. So what we need, the batching behavior needs to go like either the batch size is reached or we hit a timeout. But that timeout needs to be sort of configurable, optional. Not just set batch size to 1 and just like suffer. This plan is going to take a while. All right, I'm going to call it here because I want to eat some lunch anyway. So, yeah, this is going to take a while, and then we're going to have some back and forth. I was hoping we could get the real-time working on the stream, but I think I'll make it work off stream, and then we can check it out on Thursday. And then maybe we can do some more work on our co-streamers too while we're working. If we're going to use Claude. I don't know. It's, I kind of want to do less of that. So we'll see how that goes. Anyway, I'm going to stop here. We'll come back.